Double-clicking on the block will expose the parameters that we can adjust in the model, including the model for the fuel consumption and the speed controller. We will specify the inertia and the initial velocity. Here we can specify the units and the parameter value, and these can be MATLAB variables so that we can vary them automatically. The generic engine block has two mechanical connections. This represents the connection to the vehicle body. We'll create a rigid attachment by using a mechanical rotational reference. This signal is our throttle input. We'll specify a constant throttle of 0.5 or 50% throttle for our test. Simscape and Simscape Driveline use solver technology above and beyond what is available in normal Simulink. To have access to those settings, we'll attach the solver configuration block. This mechanical connection goes to the rest of the drivetrain. The first component in our drivetrain is the torque converter. We'll attach that here. Next, we'll attach an inertia that represents the inertia of the remainder of the drivetrain. We'll type in inertia, and here if we go into the block we can specify the inertia value, the units, and specify if this should be a runtime parameter or a parameter we can tune in simulations involving C code, such as hardware-in-the-loop testing. The next component in our drivetrain would be the transmission. To keep things simple, we'll just use a single gear, and we'll set the output of the gear to rotate in the same direction as the input shaft so that the vehicle moves forward. The next component in our powertrain is the differential. From here, we'll connect to the tire models. I'll type tire to select from the tire models that are available, and copy and paste for the left and right wheels. We'll connect the tire models to a model of the longitudinal vehicle dynamics. And so that we can see the output of our simulation on a Simulink scope, we'll connect a converter block and a scope. The converter block is where we can specify the units. So we'll set them to be kilometers per hour. At this point, our simulation is complete. We can run the simulation and view the results on a Simulink scope. Another way to view the results is to right-click on the block and select View Simulation Data. This will open the Simscape Results Explorer, and here I can see the speed of the vehicle. Here you can see it goes to about 22 meters per second, or we can set it to miles per hour. We can also look at the results of all of the other components in the network, including the amount of fuel consumed by the engine and the power produced by the engine. In this demonstration, we have seen how we can model a simple powertrain and evaluate the simulation results